Good evening. I'm Rudy El-Khouri, Dean of the School of Architecture. Thank you for joining us this evening for our first installment in the Tecnoglass lecture series this spring 2020. I'd like to take the opportunity to thank our sponsor, Tecnoglass, whose sustained support has allowed us to have a very ambitious programming throughout the years. Also, the AIA Miami for offering attendees 1.5 CEUs for each lecture. So please, if you're interested in the CEUs, please sign up here at the front. And I'm delighted to present tonight's guest lecturer, Christian Kerez. Kerez is a Swiss architect born in Venezuela. He was educated at the Swiss Federal Institute of Technology in Zurich, also known as the ETH Zurich, receiving a master's in architecture in 1988. In his early career, he worked and was extensively published as an architectural photographer. And this work in that particular field deeply influenced his architectural approach when he opened his own architectural office in Zurich in 1993 and proceeded to realize some of the most highly praised works in recent history. Notable projects include a chapel in Ober-Rialta, the Liechtenstein Art Museum, the Warsaw Museum of Modern Art, the Wholesome Competence Center, and more recently, a constellation of projects at various scales that are under construction in Germany, Austria, the Czech Republic, Bahrain, and Dubai. Kerez has represented Switzerland at the Venice Architecture Biennial in 2016 in the Swiss Pavilion, and I remember this as one of the most amazing contributions in that pavilion in years. Other high-profile exhibitions include Contrast and Continuity at the Harvard Graduate School of Design and The Rule of the Game at Toto Gallery Ma in Tokyo. His many publications include an issue of El Croquis devoted to his projects from 2000 to 2009, other monographs on his evolving body of work, or a single building such as the Liechtenstein Art Museum. Kerez is a professor of design and architecture at the ETH Zurich. He has also been he has held visiting positions at leading institutions around the world, including the prestigious Harvard GSD Kanzo Tange Chair. Please join me in welcoming Christian Kerez.
I will show some projects, and what I try this time, what is different than other lectures is to have a specific approach, a specific perspective. And actually, initially I just wanted to show some high-rise buildings, but then I thought, well, maybe this is too simplistic. And I thought could be more general, the topic, you know, what is the meaning of, let's say, verticality in architecture. So the title is actually well known, right? And architecture, you know, you could look at it. There's Richard Letterby that once said, the world is too complicated for man to understand it, and therefore he needs a model. He has to build a model of the world to understand the world he lives in, and that actually is the house. And I very much like this definition in the end of architecture in general. And if you look, for example, at this space here, it's quite generous. It's the exhibition space of Switzerland in Venice at the Biennale. But if you look, for example, at the form and scale of the chair, it's also quite limited, you know, the recognition, how big is it? It's a generous space, you could say, 5-6 meters high, but still not really very wide or open, quite limited. So when we were asked to make a proposal for the Architectural Biennale, in the interview, I said I want to build something. Also because at that time I didn't have so many things under construction in the office, so I thought that would be the appropriate approach for exhibition. And the Architectural Biennale is also, let's say, a strange institution, because all you see is models, movies, drawings, but not really architecture, not really spaces. So I thought, obviously, it's the most appropriate thing to do to create a space, and a space that should not illustrate or teach anything, that should not be something that represents something others or is used in a pedagogical sense, but just offers an opportunity how you can experience space. And this was the space that we then built and presented at the Biennale. And if you look at now, not the furniture, not the chair, but two people moving around in this space, the space becomes much bigger. It actually looks bigger than the previous space, but you have to imagine this small space is within the other one, so it has to be much, much smaller. The reason why you have a different perception of scale is because you don't see the limits of the space. The end of the space is constantly disappearing and reappearing. And besides that, you also have a texture or a ornamentation of the surface of the skin of this space that makes it impossible to really clearly kind of differentiate or measure the notion of that space. And it was the first space ever produced with purely digital fabrication, but nevertheless the, let's say, community in architecture that is very much obsessed with digital fabrication didn't love it that much. And I guess the reason is that we didn't combine it with a digital design process. There was no parametric approach. It is actually a scaling of a purely physical model. So the, let's say, digital chain is in this sense broken, and a project like this would not have been possible 10 years ago, because all the memory that the computer needs for that would not be available for a small project like this. And why do I start with this Swiss Pavilion, the lecture? It is also because the notion that we constantly used to, you know, that is not only offering a floor on which you can walk, a horizontal surface that is usable for all kind of program, but is usually also closing the same space with, again, a horizontal layer. And this space you could also look at as a vertical space that nearly gives you a Baroque feeling. For me, it was actually also like a kind of a desire, you know, to do something as Borromini did, but with different possibilities. And a space also, to create a space that kind of develops toward the ceiling, or develops in a purely vertical way. This is the outside. The skin of this space is only between 1 and 3 centimeters. And what you see inside is exact the same as you see outside, except that the texture is much rougher, because this is the side where the concrete was sprayed on of this fiber concrete. But if you now look at the same space and you look at the people, you realize that the previous pictures were taken in a very modest, in terms of scale, in a very modest space actually. When we were asked to make a proposal for some parkings in Bahrain, we looked at different parkings. Of course, we were also familiar of this very iconic parking that you have here in Miami. But there are also other examples throughout the history, as this one not built, but planned by Melnikov. If you imagine these spaces stacked over the river of Seine, as an object, it's breathtaking. But if you imagine standing inside this building, you would have, again, very flat horizontal spaces. Diagonal, of course, totally different in this sense, as most of the spaces that we are familiar with. But nevertheless, all the spaces would more or less be quite similar and, let's say, quite flat. So what we thought is, couldn't we kind of change the geometry of a slab in a way that you don't need a ramp, that you could go directly from one slab to another slab. So what we did is a deformation of all levels, so that they would collide, that they would meet one another, and that you could go directly from one surface to the next surface. This is the very first sketch model we did of one of the parkings, and looking at the 4 sides of the very same building, you also can imagine that the space inside the parking constantly changes. I show you now a series of 3 pictures, and you actually see always the same car in the same position. So this is the first one, and as you can see, the middle of the space is quite high, while the edges nearly come together, touch each other. The next space above it is the opposite. There's a compression in the middle, and the space is opening towards the outside. You can see also through the hole the opening, how you would enter from one level to the other. And this is once again the same car in the same position, and you see how the slab is touching the ground of the next level, creating again with this deformation experience of compression in the middle of the space. This is how later on the very same parking looked like from the different sides. And you can imagine that it's not only about, let's say, the sensation of space in one level and the other one, but it's also about how you would drive from one level to the other and constantly experience this shift from one space to the other. Somehow you could say a building that is just built out of slabs and columns doesn't really produce a notion of space, but while inclining very slightly these huge platforms, you very well create the notion of space. This is now a series stacking of the different slabs, and as you can see, they are nearly like topography put on top of each other. The project should be finished next year. We actually would like to start this spring the construction. This is now a construction drawing, and you can see that the building has no core. Because the slabs touch each other, they also function as the stiffening of the building. So you have for these platforms only very tall columns, composite columns, which have just a diameter of 20 centimeters. This infrastructural project is for a bigger, larger urbanistic planning of Bahrain, which won last year the Aga Khan Award, and there already exist some buildings, a visitor center by Valerio Olgiati, a garden and pavilion by Anne Holtrop, a music house by Office, and this goes together with a series of parkings, which I quickly show you. This is one opposite a mosque, and this is the reason why this parking is very low. In fact, there will be just one level now. Another larger parking where you would not go through a circular hole from one level to the other, but where the different slabs are cut into pieces so that you very smoothly, fluently can pass directly from one level to the other. So it's exactly the same principle, but with different formal elements. This is the largest of the 4 parkings, and it allows you to drive in one singular round over all 5 levels, up to the roof and in the other direction, again down. Looking in let's say, a simple way and saying, well, most buildings are just, repetition of horizontal layers. You could also say that most spaces, they are just created by division, by dividing walls. And this was a house where I thought maybe it would be interesting to not think of the wall as something separating one space from another, but by just kind of framing one space at a time. So, in fact, the moment when a wall is kind of dividing one space from another, here in this project, it actually could become a door. And you could in this sense say that this apartment house, every color represents a different apartment, is composed of totally autonomous spaces, very clearly, strongly separated from one another. Actually, it was like an attempt to create as many spaces as possible for apartments. So if you just have, let's say, one single chair, it's already enough reason to create a space out of that. And it not only gives you the possibility to have a round view in different directions, but what was for us also interesting, let's say, in the experience of an apartment like that, is that if you look now at the different openings inside, you could reveal an entire system of spaces very strongly connected, because there's no corridor, but you go directly from one space to the other. So all the flashes that you see in this diagram, they show how one opening opens a space to the next space. And between these spaces there will be no doors, so that you could also look at the apartment as actually a space that is like created out of other ones, and they all are positioned in a way that they create a different figure on a different level. But we even try to go further than that, because since all the spaces should be open to each other, the question would be, where are the side spaces, where are sanitary spaces, wardrobe, toilets, what have you? And we thought the perfect location would be in between these autonomous circular spaces. And this is an overview plan of all the different side spaces. They are quite narrow, so we tested all of them one-to-one. And we had to ask the cook from the restaurant close by, because nobody of my collaborators had the right size to test, if these narrow spaces in between are still big enough in a purely functional sense. The building is now under construction. This is a view of one of these side spaces, or how you would look from one space to the next one. And while most houses are built through, let's say, dividing walls, you never recognize from outside what is inside. But here, while the wall is a purely separating element, actually the connection between one space to the other above each other is much stronger than side by side. And you can clearly recognize from outside every singular space. And even if we never thought so much about how does the building look like from outside, which is also for me not a crucial question in architecture, but the outside is always just the result of how you imagine, how you design the interior spaces. Now that it is under construction and nearly finished, there's just half a meter missing on this picture, we also realized that this spatial arrangement leads to a, let's say, very sculptural, nearly castle-like exterior appearance of the building. But of course, these are, let's say, more studies in a small scale that not really relate in terms of building itself, you know, to the vertical dimension. I would like to show you one high-rise building, and I would like to start with this diagram that basically shows you how the weight of the building changes with each level. So if you have a building of 30 levels, the weight that has to be supported by columns on the ground floor is 30 times higher than on the top floor. This is something that is nearly never visible in tall buildings, as, for example, the Empire State Building. If you look at the floor plan, basically it doesn't change so much throughout the height, but if you look closer how the columns change throughout the building, and you see here on the left the higher part, in the middle part, and on the right the lower part, you see that the meaning of what is a column changes quite dramatically. The Eiffel Tower is, in a conceptual sense, totally different because it works with the same elements that don't change the dimension throughout the height, but the way how they are assembled and the amount of structural element changes through the height. In this sense, it's also a revelation what happens and what changes throughout the height of a tall building. And of course, the, let's say, triangular form and the composition of triangular elements is also the most efficient way how you can build a tall building, because the triangular assembly allows you to, on the same time, carry the loads throughout the building as it works as stiffening for the building. Of course, you could also imagine these triangular elements changing in numbers through the height in a rectangular form. So this was actually the principle which we called the Eiffel principle, you know, that we followed for a high-rise building of 120 meters in Chengzhou. And this is now an overview plan showing you all the triangular elements that are within this same building. And what is the benefit of that? The benefit could be that you don't need any more heavy cores. You don't need any stiffening elements that are closing the view. Everything could be open. One slab could be totally open, giving views to all directions, as this example shows. This now is a movie showing a structural model, and the camera very slowly moves upward and upward, and you see that the amount of elements changes constantly over the height of the building. On the ground floor, they slightly go out of this building to have even more stiffening. this will be a picture of the lobby, and I lately presented the project to a developer, and question was, what about costs? You know, what would be the effect? We could reduce the amount of material quite a lot, but of course, in terms of working hours, this would be quite an increase on the same time. This is the site on the Expo location for 2020 in Dubai. And we were asked after the parkings to also make a proposal for a pavilion at this World Fair. And we thought of also visiting this, let's say, plot in the desert, that it would be nice to create a huge space, space where people could come together and meet, and this space is like, let's say, courtyard in a traditional house as you see them in Bahrain. This is, by the way, also part of this Pearl Path project that the parkings are also participating. The Margil is the representative spaces where the family would receive friends and business partners are quite close because of the high temperature outside. And instead of window, you look, let's say, to the ventilation grids that bring in the cold or cooled air from outside. This is one of the patterns that you would find in a space like that. It's quite irregular, in contrast also to other Islamic countries. And we thought, actually, you know, maybe this huge courtyard or this huge open hall where you could receive people from all over the world could look like that. You know, that it's a space that is not empty, that is not a void, but is like crowded with structural elements. And of course, we thought of this space not in the sense of a drawing as from Sol Louis, but really as a three-dimensional space where these elements would go in every possible direction. The principle of the structure is somehow related to the previous project in the sense that all these structural elements, they meet in certain positions and reduces the buckling length. All these elements are quite slim. They are 11.2 centimeters. You have to imagine the whole space is 1,000 square meters, 25 meters high. But the elements are just 11 centimeters. They are not exactly the same. They look the same, but they work in a different way together. We developed this system together as we did the Pavilion in Venice with the structural designer Joseph Schwarz. On the left, you see the primary structure. In the middle, secondary and tertiary structure. The primary are elements that go from one end of the building to the other, and all these knots where these elements would meet nearly in one singular point, they are connected among each other, and they create like a circle. The building is in the underground, one level beyond, so that you don't see the side spaces from outside, but just the cube and the ramp leading to this lower level. So all the additional spaces like cooling entities or kitchen or offices or so are gathered around this large hall. This is a mock-up we did in the office to become familiar with the size, and this is the first mock-up done already several weeks ago on the construction side. Not so impressive, but if you imagine the space will be 5 times higher and approximately 30 times larger than this small area, it would totally change in perception. The movie here starts with the ceiling and then slowly goes through the walls, and you see that the openings are windows that are framing the structural elements, and the change of position, the change of direction from these windows actually only comes from the constantly changing direction of structural elements. So you could say in a certain sense this project is much more radical than the previous one, because you only have these structural elements and nothing else, no slabs. And also the facade is just, let's say, a frame for this jungle of structural elements. I show 2 schools, one built in Switzerland already several years ago, where we try to have a, let's say, densification of the program, that we use as little as possible from the existing plot. And putting one thing on top of each other is much more, let's say, interesting than side by side, because it creates a dependency between, for example, gymnastic hall, a library, a classroom, and so on. This structural element in this structural model, in this sense, is not just showing how the steel trusses handle the loads in this building, but it is also showing how the spaces are organized throughout the building. So you could look at one viewpoint of this model, and you already recognize the space that later on will come. And it's like the first sketch of the space that follows it. And in this sense, you could feel or understand, wherever you are in the building, how each space relates to another one throughout the entire height of the building. So space is not anymore a separate unit, but it's like a fragment of an all-over design. Another example, again on the 4th floor, just on the side, this is now the sketch, let's say, of the library, And this is how the library then, in the end, looked like. And we think it's always interesting, you know, if a building is finished, to also understand and see how it was built, because it's like the history of it was created, how it became what it is in the end, and seeing these steel trusses on the side is something that you still can experience in the finished building, in every singular part. And to remain this notion of, let's say, the bone structure of the building, we don't have any closed walls, but just glazed walls where you could look through. Even the handrails of the stair in the middle of the building is made out of the same glass as the walls. And in this sense, it also allows you, or allows the people that work there, live there, the pupils, to experience, let's say, the rawness of the very first gesture of building this house, of the assembly of these steel trusses. During the design process, the teachers were always afraid, you know, that they would bang their head on these inclined columns, but actually they found a much better way to use that. I tried it out myself. It's actually quite comfortable. This brings me to another project. It was an open competition in China, and we had something like 3 weeks for a program of 180 square meters. In the end, there were only 3 offices that handed in a project because time was not only short, but it was also over Christmas holidays. We thought maybe this idea, you know, to use as little space as possible from the ground could be enhanced or could be carried further. And we thought of the ground not anymore as, let's say, a park for students to recover or so, but as a farmland. This is a picture from the wetlands in the neighborhood, and it's a highly artificial setting of ponds for fishes and different agricultural fields. And we used the existing topography, the existing rivers, and completed it with additional ponds. And then we thought, you know, to use as little space as possible for this building. Or, well, you know, the brief was somehow, what would be the Bauhaus of the 21st century? And we thought that the relationship between the school and the environment should be a totally different one. And since this campus, you know, is built within very short time in China, not like in the States or in Europe, where they grow over decades, we thought it would also be possible to make one single gesture. What you can see here is the arrangement of the program, and it was the idea that we had every 4th level steel trusses, and from there on having other slabs that are just hanging or supported from these steel trusses, so that you actually have huge spaces with a height of 20 meters that would only later on be built in, or that could also change throughout the time, which you also see in this picture. We thought that the way how you go up in this building is absolutely crucial. So we opened the, let's say, safety stairs for fire escape towards the outside, towards the facade, and took the same passage along the facade in pathwalks where you could also walk on the outside of the building from the ground to the top. The program changes quite a lot with the height. On the first 3 levels you have public spaces for exhibition, auditoriums, then you would have classrooms, studios, and the cantilevering part is actually more for research purposes. I don't know why, but we lost this competition. But let's say if we would have won, you know, it would change not only my personal, let's say, situation, but it would change the perception of sustainability, of what is a university today, what is the position of China in, let's say, designing architecture and so on. So for me, you know, to do a competition is not so much about what are the best chances to win, but how far could you go? Anyway, I would like to finish with a very last project that maybe also relates the most appropriate to the title of the lecture. And it's, again, a competition for a high-rise building in Rennes of around 90 meters, mainly for student housing. And this was the given competition brief. Basically, they said they don't want just a, let's say, dull high-rise building, but they expect something much more interesting, like having 2 high-rise buildings on top of each other. And we actually thought, well, why just 2? You know, why not saying every singular slab looks different from one another? So to have a constantly changing, continuously changing outline of a building. And we thought of respecting this strange code, you know, to have this middle, a top and a bottom, but to say on these 3 levels, the building has a very specific form and it's a different form from one another. So it starts on the ground with, let's say, 2 intersecting rectangles. Then in the middle, it is an organic form that is kind of the most compact possible. And it starts to expand again on the top floor to give a better view for these expansive apartments that would be probably for the football stars of Rennes. And then, you know, not to do a collage where you have 3 different things on top of each other, but saying that every single level is one step in a continuous transformation from one form to another form. This is now an overview of all different apartments that we would have inside this tower. And you see that actually the division from one floor to the other doesn't change so much. And the structural system actually works like that you never have a cantilever of more than 8 meters, or never have a bigger distance between core and shell than 8 meters. In this diagram, you see each outline of each floor and the distance to the central part of 8 meters, and you see that this core arrangement actually always fits on every single level, so that you still could have quite an economical thickness of the slab. This is now showing in a movie, you know, how the form constantly changes, how the positioning of the columns on the exterior very slowly changes. The inclination actually is always less than 10%. So, you know, for structural reasons, it's not a big change to having vertical columns. And what also interested us in this, let's say, design was that you would get a tower that would look totally different on each side, and where you would have a vertical perspective. Looking down or looking up this building, you could recognize it. You know, it's not just a front, but it's really an object that is built for this unique perspective that you have if you're close to a building, looking up or looking down this building. These now are the 4 sides of the very same building, so that as an orientation in the city, it always would give you a totally different perspective. You see also the setback of the facades for the balconies. Yeah, we were visiting 2 days ago the tower that Barke Ingels built here. That we knew, of course, but let's say the approach of how we use the structure, or how also the outline of the shape transforms. And if you look at the building itself, you cannot clearly identify what is this form, or what is the overview of all these different outlines. Even if it's, let's say, built on very simple forms. It was a collaboration with the office Brüter from Paris and David Kras from Rennes. So these buildings here in the foreground are buildings by Brüter. And the idea, let's say, the urbanistic idea was that to create spaces that constantly change in between the different buildings. I mean, a high-rise building basically, you know, is just core and shell, and this was also like an attempt to come up with something that doesn't question that. You know, it's not about the most exciting typologies in apartments, which you can anyway not do if you have to deliver several hundred apartments. You know. So it was an attempt, you know, to take that as a starting point and say, okay, a tower is just core and shell, so what, you know? But how do they relate to each other? What is the specific relationship between them? And only out of that came also a specific, let's say, formal approach. This is now a close-up to, you know, to imagine how this structure could be lived in or could change with the inhabitants. And this movie is actually a zoom in out of this rendering. Thank you very much.